Time for this recording is to talk through systems of linear inequalities. Systems of linear inequalities and how we solve them. Unlike systems of linear equalities, our solution will be multiple points. There'll be a lot of different x value coordinates, x and y value coordinates, that will solve these equations or these inequalities. In a system of equations, you're looking for one solution, no solution, or infinite number of solutions. In this case, though, we're looking for a shaded region that represents all possible solutions. And there'll be more than one xy coordinate that makes these inequalities true. So, first step is to remember how to graph an inequality. And then we just graph two of them and find out where they overlap. So let's talk through some of the ways to graph inequalities. So the first thing, remember, is we're going to graph this like and equals. So I'll rewrite the top equation. We're going to look at this as if it was an equal sign and ask ourselves, how would I graph a linear equation? Well, this is already nice and neatly set up for us into y equals mx plus b. So I'll just graph it that way. This -5 represents my y-intercept. The slope, 2/3, represents rise over run. The top number is a positive number, so it tells me to go up 2. The bottom number is a positive number, so it tells me to go to right 3. So from my y-intercept, I go up 2 and over 3. And I can do that as many times as I need to until I think I've got enough points for a nice, neat, straight line. Okay, now before I draw that line, here's where things change. I have to ask myself, is it a solid line or is it a dotted line? And if the y is equal to and less than or greater than, then it's a solid line. But if the y is just less than or just greater than, then it's a dotted line. Mine is a less than or equal to, so it is a solid line. I draw a solid line through my points, and then I shade. Now, here's where different people have different ways of shading. Here's what I look at. If we recognize what this line represents, it represents every xy coordinate that makes that equation true. So if this says y is less than the line, because the line represents what values for x will make this equal to y. Well, that's the line. Every xy coordinate on the line, or every x value that matches up with the y value on the line, the y is equal to the x. So if I read this as y needs to be less than the line, then that's pretty easy. Let's just pick a point. I'm going to pick this point right here, if you can see that. I want every y value that is less than that y value right there. That y value right there is a -3. What y values are less than those? The ones below or the ones above? The ones below. So I want everything down here. If you don't like that one, pick a different y value. How about 1? When y is 1, what y values are less than 1? All these down here. No matter what y value I pick on the line, or what point I pick on the line, when y is less than, we're shading down here. Okay? So when I do this, I don't actually shade. I just make arrows. Okay? So let me get rid of all my shading. So I just make an arrow that says, I want everything that is down here. And the reason is, I have another line to graph. And if I shade a bunch, which some books do, then you're just going to have all this overlap, and you're looking for the darkest area. Well, which area is the darkest? And it just gets confusing. So I'm not going to graph the final overlapping shaded area until the end. All right, next thing. Let's graph that second line. I'm going to rearrange this into y equals mx plus b. To do that, I subtract the x. Next step, I'm going to graph it just like I graphed the other line. My y-intercept is 4. My slope is a -x. Well, what that really is a -1. And as a fraction, it's a -1 over 1. The top number says a rise that's negative, which means I go down 1. And the bottom number is a 1 that is positive, and so I go to the right 1. So from the positive 4, I go down 1 and over 1, and I just continue that same pattern on down here. This one is dotted because it's not equal to. So I have a dotted line that cruises, dotted, dashed, doesn't really matter. Okay, now I want every y value that is greater than that line. So I want everything up here that is greater than that line. Now a system of inequalities says I want the overlap. What region makes both of those inequalities true? The region that both arrows are pointing to, which is that region there. That's it. Graph each inequality, find the overlap. All right, whenever you think you're comfortable, hit pause, come back, and I'll talk through it. Okay, question 1, or equation 1. I'm going to rewrite that or solve that for y. So I'm going to subtract 2x next. I'm going to divide by -3. When I divide by a negative, remember I have to flip the inequality sign. I divided by a -3 here, here, and here. This I'm just going to drop the negative signs because a negative divided by a negative is a positive. And a +6 divided by -3 is a -2. So my y-intercept is a -2. And my slope is up 2 and over 3. And I follow that same pattern until I think I have enough points to get a nice line. It is dotted because my inequality says simply greater than. All right, next one. Solve the second equation for y. I will do that by subtracting x, divide by, whoops, I was thinking ahead, divide by 3. The number in front of that x is a 1 right there. So this is really a -1/3 x. Dividing the number in front of the x by 3, dividing the 9 by 3, dividing the 3y by 3. I did not flip the inequality sign because I did not divide it by a negative. I divided into a negative. I did not divide by a negative. My y-intercept is a -3. My slope says go down 1 and right 3. And I get that graph there. This one is also dotted. Oh, sorry, I forgot to do my shading on the other one. Let's go back and shade. I want every y value that is greater than the line. So here is my line. The y values that are greater are above the line. In the second one, I want every y value that is greater, the ones that are above the line. Where is the overlap? The ones that are above both lines. So everything out here is going to satisfy both inequalities. And you don't have to get too crazy in your shading, but this is my shaded area out here. Okay? All right, let's try another one. Your turn again, or whenever you think you're comfortable, give it a try. Hit pause, and I'll come back, or then come back, and I'll explain it. Okay, here's a new one. X is less than 4. That says it doesn't matter what y is. X just needs to be less than 4. So the first question then is, where is x equal to 4? Well, x equals 4 all along this line right here. It is dotted because we don't want it to actually equal 4. We want it to be less than 4. So now we have to think about it a little different than what we did before. We were looking at y values before, and y values that are above the line are greater than, and y values that are less than the line are less than. What about x? Which x values are less than? The ones on the right-hand side of the line or the ones on the left-hand side? Pretty obvious. The lines, or the numbers on the left-hand side of the line. So I know I only want the region to the left of 4. All right, second equation. I'm going to rewrite into y equals mx plus b. My slope is a negative 1 over 1, and my y-intercept is a negative 2. Negative 1 slope says go down 1 and right 1. I do that over and over and over. It is a solid line this time. So I have my solid line. And I want everything that is greater than, everything that is above the line. It's down here too, but I know it's not over in that region. All right, last one. I'm going to rewrite that in terms of y equals mx plus b. So I'm going to add 2y this time. You could have subtracted 2x, and I'll do it that way also. You should see that it's the same. So I added 2y. Why did I choose to add 2y instead of subtract 2x? Every other problem on this recording, I've subtracted the x's or I've added the x's. What made me add 2y instead of subtracting 2x? My goal was to get the y to be positive. The reason is because when you divide by negative, something else has to happen, and sometimes we forget to do that thing. So instead of having to divide by a negative and flip the inequality sign, I just thought, oh, I'll move the 2y over, and that way I don't have to worry about it. Now I divide by 2, and I don't flip the inequality sign. And I read that from the variable I'm trying to relate to, meaning I want to know how is y compared to x. So I start with y. And y needs to be less than, arrow points a smaller number, x. So let's graph. I could flip that and make it look like this also, correct? Those are the exact same statements. Before I do the graphing, let me show you the other way. What if I move the 2x over? What if I did this? What if I said a negative 2y is greater than or equal to a negative 2x? Now when I divide by a negative 2, I do flip the inequality sign. And a negative 2 divided by negative 2 is just y is less than x, which is what we just wrote right there. Okay. Y-intercept, a number out here. Well, there's no number out there. So it's assumed to be a plus 0. Not assumed, it just is a plus 0. There's no number out there. My slope is a 1. There's a 1 in front of that x. 1 as a fraction is up 1 over 1. This one is solid, so I have a solid line cruising through here. And I want y to be less than. I want everything that is less than that line. Above this line, less than this line, to the left of this line, I want everything that is in here. Just be careful on your shading. Just keep it inside a little triangle. What's that saying? Everything I needed to learn, I learned in kindergarten, like coloring. Just color inside the lines. All right, there is the solution to that system of equations. All right, I think this is my last one I got up here. Give it a try. All right, so first equation, I'm going to subtract x. So I get negative 3y is less than a negative x plus 9. Divide by negative 3, I flip the inequality sign. A negative 1 divided by a negative 3 is a positive 1/3. A positive 9 divided by negative 3 is a negative 3. So my y-intercept is a negative 3. My slope is 1/3, and so I graph that line. It is dotted, and so I dot my line cruising through something like that. These y's need to be greater than, so they're looking at everything above. We're looking at everything above that line. Next one, y-intercept. It's already nice and neatly set up for us. My y-intercept is 1. My slope is a negative 1, right? That's a negative in front of that. Put it over 1, so I go down 1 and over 1. And so I get something like that. It is solid, though. And we are shading below that line. So it's everything in this region right here. And we got it. All right, that is solving systems of inequalities.